Hi everyone, welcome to the channel Math for me and you. Let's learn maths together. Hello everyone, today we answer these questions from exercise 1.3. Look at several examples of rational numbers in the form p by q, q not equal to 0, where p and q are integers with no common factors other than 1 and having terminating decimal expansions. Can you guess the property of q? Here, through many examples, we have to find out the property of q. What is q? Q is the denominator. For that, we will consider some terminating decimals because it is talking about terminating decimals p by q form. 0.1. 0.1 is 1 by 10, we know. Its p by q form is 1 by 10. What is 10? 2 times 5. So we can write with its prime factors 2 and 5. Next one is 0.43. We can write this as 43 by 100. Numerator 43 and denominator 100 because after the point 2 digits. So we can write this as 43 divided by 2 square times 5 square. 100 we can split as 2 square and 5 square. Next very common number is 0.5. It is half, 1 by 2. And that means what are the prime factors? Only 2. The denominator 2 only. Next one is 0.04. This is 1 divided by 25. And what is 25? 5 square. So we can write 1 by 5 square. Next we consider a decimal number with 3 digits after the point. 0.413. How to write the p by q form? 413 numerator and denominator is 1000 because it is after the point 3 digits. When we look at the denominator, we can write the prime factors as 2 power 3 times 5 power 3. Next one, 0.025. Its p by q form is 1 divided by 40. What is 40? 8 times 5. That means 8 is 2 power 3. So we can write 2 power 3 times 5. So 40 we split it as 2 power 3 times 5. One thing we can notice from all these examples, all these p by q form are the denominators contains only 2 and 5 as the prime factors. Or we can write the property of q of these type of numbers. They contains only 2 and 5 with the powers. And powers we can write generally m and n, where m and n are whole numbers. That means 0, 1, 2, 3 like. First one 2 power 1 times 5 power 1. Second denominator 2 power 2, 5 power 2. Third only 2. So we can write 2 power 1, 5 power 0. Only 5 power 2 we can write 2 with the power 0 and 5 power 2. Next is 2 power 3, 5 power 3. Last one 2 power 3, 5 means it is with the power 1. So we can see all these examples having denominators of the form 2 power 1, 2 power m times 5 power n, where m and n are whole numbers. These are terminating decimals and their p by q form, and p and q having no common factor other than 1. Question number 7. Write 3 numbers whose decimal expansions are non-terminating, non-recurring. So we need to write 3 numbers non-terminating, non-recurring. Very common examples root 2, root 3 and pi, because non-terminating, non-recurring are irrational numbers. What is root 2? We can write its decimal form. Decimal form is 1.4142 1356 etc. See, all the digits are different and it's non-terminating. It's not stops. Next is root 3. What is root 3? Its decimal form 1.73200508 etc. It's also non-terminating, non-recurring. Next pi. Pi, when we look at its decimal form, it is 3.1415 9, 2, 6, 5, 3. And these numbers also 5, 3, etc. These numbers also non-terminating, non-recurring. These three numbers are irrational numbers. Next question. Find three different irrational numbers between the rational numbers 5 by 7 and 9 by 11. So we need three different irrational numbers between 5 by 7 and 9 by 11. 5 by 7, 9 by 11 are rational numbers. Their decimal forms are non-terminating, recurring. 5 by 7. What is the meaning? Take 5, divide by 7. 5 is a small number. 0 times we can divide. So 5. Now we change this as a decimal by giving point and many zeros to the right side. Now we consider after the point 0. So give point in the answer and join. 50. 7 times 7, 49. Balance 1. Next 0 bring down. 10. How many times it goes? 1 time. 7. Balance is 3. Next 0. So the number becomes 30. 7 times 4, 28. And the balance is 2. 30 minus 28. We join 0 with the 2. It is 20. So it is 2 times 7, 14. The balance is 6. And that means it continues its division. So we can write the answer as 0.7142. We put etc. Many numbers will be there, but they repeat. Okay. But we write this. We need at least 3 digits after the point. Next is 9 by 11. 9 divide by 11. Again 9 is smaller number compared to 11. 0 times only it goes. And then put point and more zeros towards the right side. How many zeros we can put? We can put any number of zeros because it is after the point no numbers. Now we join point and 0. So the answer become point and 90. How many times? 8 times 11, 88. Balance is 2. Next 0 is 20. 1 times 11, 11. Then balance 9. Then 0 down, 90. 8 times 11, 88. And balance is 2. Then 20. And again 1 time 11, 11. And balance is 9. That means this process continues. So what answer we get? We get the digits 8, 1, 8, 1 repeat. So the answer 0.81, 81, 81, etc. We need 3 irrational numbers between these two decimals. The question is to write 3 different irrational numbers. So we can write irrational numbers. What we understand from irrational numbers, what type of decimal form they have? They have non-terminating, non-recurring decimal form. So they must be non-terminating, non-recurring decimals. Now we are going to write 3 decimals of this type in between 0.7142 and 0.8181, etc. So this is very easy. 0.7142, this number, after that we need a decimal number. So how to write? We will write this as irrational numbers we have to write. So we will write this as 0. After 71 we can select a number 72, 73. It's up to you. I'm going to write 0.72. It is more than 71. So we can write 72. When you write irrational numbers, the digits must be different and it's not stopped. So we can see non-terminating. And let me select different digits. Simply from my mind, I'm selecting some digits which are not same. 721538 0, then 7 0 4 2, or like this. So we have selected a number and this is irrational. Next, let me write a number. This is easy to write as an irrational number. After 72 we can take 73, 74, any number, but I am taking 75. Simply I have selected that and see the pattern. I write 750. After that 7500, then 75000. So this is easy to write an irrational number. We can write an irrational number very easy way. And now just below 0.81 we can write a number it is 0.80, 800, 8000, 8000, etc. So very easily we can write irrational numbers. 3 decimals which are non-terminating, non-recurring. Irrational numbers between two rational numbers. Next question, we have to classify the numbers as rational or irrational. See, what are rational numbers, irrational numbers, what's their specialties, you can check from here. First is root of 23. Is it rational or irrational? You can see under root number is not a perfect square. We cannot write it in the form integer by integer. So this is irrational number because we cannot write it in the form p by q, where p and q are integers. Examples, many examples we can write. Root 20. 20 is not a perfect square. Root 11. Root 18. Root 24. All these are examples. I have just wrote here two more examples, root 20 and root 11. Look at the next question. It is also a root number, root of 225. But what is the under root number? Under root number is 225, a perfect square. We can write its square root as 15. And what is 15? When we write 15 by 1, we can write its p by q form, and it is p integer, q integer, numerator, denominator. So this is a rational number. A root and under root number is a perfect square, then we can say it is a rational number. Next is 0.3796. This number is a decimal which terminates. Terminating decimal we can write in p by q form. So this is also a rational number. Next, 7.478, 478, etc. That means here after the point digits 478 repeats. We can write 478 bar. Non-terminating, repeating or recurring decimals are rational numbers. So this is also rational number. The reason is non-terminating, recurring. Next number is 1.10, 100, 1000, 10000, etc. This means it is non-repeating, non-recurring decimal. So this is a rational number. If you like this video, please subscribe my channel. Hope this video is useful to you. See you with more videos. Thank you.